In this video, I'm going to go over the advantages and disadvantages of a repeated measures t-test. We'll talk about advantages first, and then we'll talk about several different types of disadvantages. So one advantage of a repeated measures t-test is it uses the same individuals in both treatment conditions, which requires fewer participants. This is a big advantage for researchers. Sometimes we're struggling to get enough people in our studies, and we can get more bang for our buck with fewer participants when we do a repeated measures test. It's also good for measuring changes over time because I look at a certain phenomenon at two different time points. And this is used in research on learning and research on human development as well. But the primary advantage of a repeated samples t-test is it reduces the variance and error by removing individual differences. You're using the same people at pre-test and post-test. So all of the things that might be sort of peculiar about that one person is going to stay consistent from pre-test to post-test. In other words, you are eliminating other factors that might explain the result that you're seeing. So using the same individual and calculating different scores has two important consequences. So a different score for each subject provides an indication of how much difference there is between the two treatment conditions. So again, we use a different score. And then subtracting the values to obtain those different scores removes those individual differences, like I said. So if all subjects have about the same different scores, then it appears that there's a systematic difference between the two treatments. That makes sense, right? If the D scores, the different scores, are similar, that means smaller variance, which means standard error is small, and that leads to the greater likelihood that a t-statistic will be significant. So I'm going to show you some data to demonstrate these points. As you look at these data, we have 5 subjects and we have the score on measure 1 and measure 2, time 1 and time 2. And then we calculate a different score for each individual. And as you'll notice, they pretty much are pretty tightly clustered, these different scores. The scores themselves are kind of all over the place, but when you look at the different scores, each individual has about the same change over time. First of all, the change seems to be positive over time. And second of all, they're all pretty close. So what this means is I don't have a lot of variance here, which means I'm more likely to have a significant t-statistic. But let's take a look at subjects B and subjects E. As you'll notice, there's almost a 50-point difference between their scores here. There's a lot of individual differences here between these two people. But those differences get fleshed out when all it is that we're looking at are the different scores for each individual. So the variance of these scores is pretty high, but the variance of the different scores is not. And so it's showing that consistently something is happening in between individuals. Individuals might vary a lot in their actual scores, but the direction of that change is consistent amongst all of the participants. So again, this is the key part. This different score produces a smaller standard error, which increases the likelihood of a significant t-statistic. So there are disadvantages to doing a repeated measures t-test. First of all, we can have what are called outside influences. So these are factors that are outside of the experiment that may interfere with testing when you're testing somebody across time or across treatment trials. So an example of this would be mood, health, or motivation. Things change between time 1 and time 2 that may have nothing to do with the study. So these outside influences that can intervene in between your trials can interfere with your results. And you can have something called treatment influences. And there is the risk that exposure to the first treatment or the first time trial might cause a change in the second trial, just the treatment itself. So one way that this happens is through practice effects. So the first treatment might cause improved performance in the second treatment. So let's say that my measurement is a test of somebody's ability to do something. Well, just by taking that first test, that person might improve in their ability on the second test. So the experiment itself might be responsible for the change that we're seeing between the first trial and the second trial. Also, we have something called order effects. How treatments are administered might influence the scores in the second treatment. So let's take a look at what we do when we have problems with order effects. We can counteract this through something called counterbalancing. It's a way of mitigating these order effects. What we do as researchers is we vary how the treatment is presented. So if I have two separate types of situations, I'm going to maybe give half of my participants the first type of situation and the other half the second type of situation. Let's see what this might look like. So for example, this is a PSY 290 research study asking people to rate these companies, Dunkin' Donuts, Starbucks, and Dutch Brothers. And it was found that Starbucks was rated higher when it was presented first. But when it was not presented first, it was rated lower. And what does this mean? Well, maybe when you see Starbucks immediately, you have a certain feeling about it. But if you see Dunkin' Donuts before Starbucks, that could change the way that you see Starbucks. Order matters. And so what we can do as researchers is we can vary the order in which we present things to our participants. Here's another example. Let's say that I have a measurement that I'm using in a study that has easy, medium, and hard questions. Well, the order in which those easy, medium, and hard questions are presented may impact the results. For example, if people are given easy test items, that might scaffold them, make it easier to answer the medium test items, which makes it then a little bit easier to answer the hard test items. So there might be a learning curve that's happening here. So you don't want everybody to have the same order, because then you don't know if it's the order of the items that was responsible for the difference. So what you can do is split it up and make sure that some people have easy, medium, and hard questions. Some people start with medium questions, go to hard questions, and then go to easy questions. You're shaking it up so that the order in which something is presented isn't really what's going on in your study. Here's another example. Let's say somebody started with hard questions and then they gave up. So you don't want everybody starting with hard questions. You want to break it up so that the type of question itself is not what it is that you're measuring. I hope this made sense. So repeated measures, t-tests, definitely have their advantages, but they do have some things that they have that are considered disadvantages as well. So in the last video, I'm going to speak with you very briefly about effect size with the repeated measures t-test.